Hello guys, this is Abdurrahman Gilal. In today's short presentation, I will be explaining you the basic definition of software and software engineering. Also, I will be trying to tell you the importance of software engineering and when and how do we consider that the software is successfully developed or we are successful in our project. So before I go further to explain anything about the topic, I realized that it is good for me to start with the simple understanding or a simple definition of software engineering. In simple words, I would say software engineering is a systematic application of engineering approaches to the development or operation or maintenance of software. So what I mean is that it involves the use of engineering principle and methodologies to create software systems that are reliable, efficient, and scalable. Software engineering encompasses a range of activities that include, let's say, requirement engineering or requirement analysis, design, coding, testing, deployment, and maintenance, all aim to actually produce high quality software products. So I will try to directly jump to the need that why should we be learning software engineering first. Then I will go and slowly explain that how does software engineering look like. And then I will conclude my presentation with explaining the success factors of software products. Okay, so I quickly we would like to show you a survey conducted by PwC. They actually saw like global top 100 companies by the market capitalization. So what is the point to actually bring it to you is just to show you quickly this particular, how to say, table that if you see top 100 global companies, 1 to 20 by market capitalization. So let me highlight based on the pointer. Okay, so you're gonna see here that we've got this Apple on top, and Apple is information technology. So if you see the second one is a Microsoft. So, and the Microsoft once again is information technology. So if you keep going, you're gonna see that the fifth number is also, something related to technology. So it is clearly telling me that the top 20 companies or like world famous companies are basically coming maybe around 8 or 9 from just my IT. So when you talk about IT, definitely you talk about software. So the software is not a detached part of IT. So I would rather feel that it is very important that if I say what who are the top richest people in the world, and you're gonna see that there will be Bill Gates in one of them. You will see Mark Zuckerberg here, one of them. Let me quickly see if I can show you the list here. So let's just start. So just to see like top 10 richest people in the world. I'm not sure, but you're gonna see that this Mark Zuckerberg, we know that Mark Zuckerberg actually owns Facebook. I'm not saying the authenticity of this survey, but at least I have seen so many places where these people are coming on the top, like Bill Gates. What do they actually own? The top businesses and the top richest people, they basically own a software company, or at least they are having something related to software. So it is telling me that the world paradigm is shifting from the big, physical marketed companies to the soft marketed companies these days. So it is showing me that there is something very big is happening in there, right? So it's good that I'm gonna see that okay, richest and billionaires and trillionaires are coming out from software market, so I should be working in it. But that's not actually is the direct scene in it. If we see another survey that is produced by Standish Group, I'm just gonna quickly give you the importance of this. It's just a report from 2050. It's not so different from the previous ones, but at least you're gonna get some idea that how until 2015 things look like in software industry. So the Standards Group collected data from several years, and then they realized that the success of software is not as expected. You're going to see that the success rate is everywhere is lesser than the failure rate. So what is it? I'm going to explain. So basically, whenever we say anything in software, it's going to be a successful software. What do we mean from that? We basically mean that uh, I rather say, there are three parameters, I would say, not okay, give me a second. Let me just start this. Yeah, this one. Good. Okay, so, oh, sorry. Give me a second. I'm extremely sorry about this mouse and everything. Okay, so I would say when the software is based, like if the software is given based on requirements. Sorry about my drawing. And based on time, like when I make sure that everything is on time, and based on budget, let's say the third one here. So the budget. Okay, so sorry about this first of all. Let's say, so I'm gonna say that anything that is based on time, based on requirement, and based on budget. So if three parameters I consider, then I'm going to say, okay, this is successful for me. So whenever I, as a company of software development, is getting a project, and if I deliver based on requirements, based on budget, and based on time, which whatever we decided, then this is going to be said that, okay, this software is successful. So the Standards Group has actually measured these parameters before they concluded their success and the failure. So traditional resolution for all types of projects, you're going to see the success is less everywhere you see. So 39% is success, 37% is success, and so on and so forth. So here they mention failed and challenge. So what do they mean? Failed means did not work at all. So the project failed. And the challenge means they submitted to the clients, but the clients had somehow not accepted the delivery of the software. So basically, majority of the projects are being either failed or being challenged. So if you go further downwards, you're going to see that the generally overall project size by chaos resolution. So success is 6% if you have a big project, and the success is just 11% if the project is large, medium, moderate, and small. I can see that if you get a small project, then the success rate is higher. So managing a large project or grand project is getting crucial and not easy. So these results are trying to tell me that there is not something good is happening in software market. So what we see on the first hand is that software is giving us billion and trillion dollar markets, but on the other hand, the this large or grand software success is just to 6%, which is a crucial stage. So now my question will be like, if I am, sorry, sorry about that, if now I am how to say a person who is trying to know that what could be the reasons for the failure. So that's important. If I do not know the reasons of failure, then I will never be able to make them correct, right? So several people have concluded their research or their findings by saying it the requirement collection. When we collect the requirements, we do not collect requirements properly. So we either have misunderstanding, or we have unclear understanding, or we do not collect the educate requirements. So once we do not understand the requirements of stakeholders or users, so definitely we're gonna make software not as per their desires. So the first one is the requirement is not gonna achieve. So let's say in a good case that we understood everything clear, then this comes like maybe we do not plan it nicely. What time should be given to what type of activity, how to organize our, resources, how to give scope to our, task, and what causes the cost overruns, what causes the project delayed. So many things can happen and that we have to keep in our eyes before we start developing to it. Right. And sometimes when we are working on on a software project, so it's not, just it because we have got the requirements and we have set the planning. So there is a need once again that we have to keep involve our stakeholders. So one of the major value factor of software, these days is a lack of stakeholders involvement. So what I mean is that we do not involve this right type of stakeholders at the time of development. We just keep them and then we try to bring them, at the level when the product is almost ready. So at the end, like if I am teaching you something today in the first section and then you told me I didn't understand that particular thing, so it's easy for me to understand you at that level instead of like when we are finishing this course, let's say. So this is going to be a big problem to understand everything at the end, right? So it's good to have the involvement of stakeholders at the beginning. So this is one of the another failure reasons. And poor communication, and not only with the stakeholders but as well as among the team members, because these days software are not developed by one person. So these days we have teams that develop software, and luckily then the world has become a global village where people are working in different places in the world. So sometimes the language can be a barrier, sometimes time can be a barrier, sometimes understanding of communicating requirements can be a barrier. So we have to make sure that we have clear alignment and clear goals and clear ways of communicating with our developers as well as stakeholders when we are working on any software which is large scale or any type of scale of the project. So this is one of the reasons, that the failure reason. I want to say that the poor requirement is a reason, inadequate planning is a reason, lack of stakeholder involvement is a reason, poor communication is a reason. So, and so many people have also said that when we hired people, we do not hire the skilled people. When we, test the project, we do not test adequately. So there are these some other reasons they can come. So in this course, we will be trying to understand the important factors that actually can cause the failure in software, in development or success of the software, starting from requirement, design, development, testing, and communication. So this is very important for us to understand in this course. So let me go back to this. Uh, how to say this chaos report. I'm just gonna quickly give you an overview that I just found this tutor is good for us to start our software engineering. So let's say this author has actually started saying it that the software engineering, as per the definition, is an engineering discipline which is designed to apply engineering principles to design, develop, test, or validate or maintain the software. So it has given us some sort of sketch that planning and then designing and then development and testing, deployment and maintenance. This is how I would see this. Okay. So let's quickly see then what is software, the first thing. So if I have a computer as a complete system or information technology system, so I do have majorly four parts. So what I'm going to do is then the four parts. Let me try to draw it if I can easily draw. Let's see if it works. Okay. So usually hardware is one of the parts. Okay, so the second part is, let's say, software. Okay, and the third part is, let's say, user. An important part maybe data. So all of them are actually making a computer system, isn't it? So this makes a computer system. So I'm gonna say like hardware is all the physical components that make us. So it could be anything that we see. It could be mouse, keyboard, screen, could be wire or wireless system or anything that actually makes up a shape of computer, right? Like in a human body, my eyes, my how to say my hands, my nose, my ears, everything is considered to be hardware, right? So what is software? Software is, as per this definition, basically it's a program or set of instruction that guides the hardware to work, or to do some action, right? So hardware is actually these days controlled by software. Not only these days, actually since the beginning. Okay, so I would say the software is a set of instructions to guide some part of some part of software. So what's user? User is anybody who's using computer. Right? Human can be user. These days, computers are users, and then like machine are users, and even in fact, I've seen some monkeys also being users of computer because everybody's nowadays using computer. Let's say. So, and the data, anything that we pass to computer, anything that computer returns. So everything that comes through or go through is considered to be data. So data is also one of the very important unit. So keeping everything in view, I'm gonna say like, okay, in order to grab the data from users, we need to create some software. In order to receive the data from hardware, we need to create some software. So software is becoming integral part of, you know, the computer system. So I'm not going to say it's only software, but we need all these four parts in order to run the computer systems, right? So let's run it and then see like, is there any difference between program and software? Yes, program is a unit or is like a, small part, or software is a big part, definitely. I would say in one program, we can have one or two tasks, but in one software, we may have one or two programs. So I'm just gonna make a hierarchy like that way. So let's jump in then. What is engineering of it? So if it's very, very easy. So when the size increases, when the users increases, when the data increases, remember the four parts of computer, and the hardware increases. So definitely we cannot do just simple development. We have to plan like engineer. So software, then do not work on software first, engineering first. So there we need in engineering. Okay, then I'm talking about engineering. So engineering is a scientific field that involves taking the scientific understanding of the natural world and using it to invent, design, and build things to solve problems and achieve practical goals. So just keep in view that basically they focus more on calculation, precisions. They try to make sure that anything that happens is calculatable, which means that if you want to repeat it, we can repeat it. So some factor which natural things happen. So in order to calculate the precision in them, we definitely need some engineering paradigm for them. So then what becomes software engineering? So software engineering, as per the IEEE definition, that software engineering is a systematic design and development of software products. Here we're gonna say software products, right? And the management of the software process. It has as one of its primary objective the production of programs that meet specification and are demonstrably accurate, produce on time, and with budget. So all those three things, requirements, budget, and time. So three things, the focus of this engineering process, right? So I'm not going to discuss this layer technology that what is quality, what is process, and what is method, and what's tool. Let's just like simply recap what we discussed, that software these days is actually creating more problems because of its size, because of its scale these days. So many people are using it, and because of the even different technologies and the developers themselves. So there are so many problems that we already somehow discuss. But let's say then the software engineering is basically helpful for us so that we can do scalability of the software. We can make software on time to the market, and we can also work on accepting the changes because the modern world is changing technologies, requirement of user, and the way the people use the system is also being changed. So adaptability in terms of change acceptance is also being part of the software. So I think software engineering will help us to not only make good software, but in contribute in a bigger spectrum for the betterment of the society. What I mean is that successful software will contribute to the successful, use or successful, how to say, and development of the nation. So thank you so much. If you got any questions, please do not hesitate to drop me comment or email me. Thanks a lot, guys.